Okay, so picture this. You walk into your home, and there, waiting for you, is a humanoid robot,
Hmm.
ready to help you out with chores, maybe even make you a cup of coffee. Sounds like something out of a movie, right?
Sounds pretty futuristic.
But it's actually closer than you think. And today, we're going to dive deep, really deep, into the world of how these incredible machines are built.
That's right. We're going way beyond those, clunky robots you might have seen in those old sci-fi flicks.
Yeah.
We're talking about humanoids, robots that are designed to move and interact with the world just like we do.
So more than just nuts and bolts then. I mean, there's got to be more to it than that, right?
Way more. We're talking cutting-edge materials, artificial intelligence, AI, sensors that can actually mimic human senses.
Wow.
Even the challenge of recreating natural movement, making these robots move with fluidity like a human.
Okay, I'm hooked. But where do we even begin with something this complex?
Well, just like building any kind of structure, you got to start with the foundation, in this case, the robot's skeleton.
So what are we talking? Just like metal bones? I mean, is that it?
Well, not just any metal. Think aluminum for lightweight strength, steel for those heavy-duty joints, the ones that have to handle a lot of stress.
Uh,
And get this, even titanium.
Titanium? Isn't that what they use in like spaceships and stuff?
Yeah,
What makes it so special for robots?
exactly. Titanium has this crazy strength to weight ratio, super strong, but not heavy at all,
I see.
which is like essential for robots, right?
Right.
They need to be powerful, but also agile. Imagine a robot smoothly lifting something heavy or moving with like a dancer's grace. Titanium helps make all those movements possible.
Okay, that makes sense. But hold on, I mean, it can't all be metal, right? What about all those super lightweight materials, the ones you hear about all the time?
You're absolutely right. It's not just about metal anymore. We're seeing amazing things with composite materials these days, like, for example, carbon fiber.
So carbon fiber, what's the big deal with that?
Well, imagine it's like the robot version of a featherweight boxer, strong as steel, but incredibly light. This stuff allows for quick, super precise movements, even when the robot's lifting heavy objects. That's why you often see carbon fiber being used in robotic arms, the ones that need to be both strong and nimble.
Pretty impressive.
Mm.
Any other materials in the mix?
Yeah, we're also seeing fiberglass reinforced plastic.
Okay.
It's another option that gives us that balance of strength and weight that we need. And the thing is, the research never stops. Scientists are always on the lookout for even better materials, lighter, stronger, you name it.
It's like a constant evolution.
Exactly.
So I've got this amazing framework, right?
Mm-hmm.
But how do we actually get it to move? I mean, that's where the muscles come in, I guess.
Exactly. And in robotics, we call them actuators.
Actuators.
Yep, they're the driving force behind all of the robot's movements.
Okay, so break it down for me. What kind of muscles are we talking about here?
Well, to be honest, replicating the complexity of how human muscles work, it's one of the biggest challenges in robotics.
I bet.
But, we've got some pretty amazing tools to work with. For those small, really precise movements, like let's say in a robot's fingers, we use electric motors and servos.
Uh-huh.
They're fantastic for fine-tuning those delicate actions.
So it's like tiny motors for tiny movement.
Exactly.
Yeah.
But sometimes you need raw power, like for lifting heavy stuff or moving large limbs. And that's where hydraulic actuators come in.
Oh?
They use pressurized fluid to generate a ton of force. It's like, like a super strong muscle contraction.
So hydraulics are like the heavy lifters of the robot world.
You got it. And then we've got pneumatic actuators.
Okay.
And those use compressed air. Perfect for those lighter, more gentler movements.
Yeah.
The ones that need a soft touch, like if a robot was picking up something fragile.
Got it.
Yeah.
It's fascinating how you use all these different systems, to create such a wide range of motion. It's almost like you're giving these robots different types of muscles.
It's a great analogy. And honestly, the decision of which actuator to use, it really depends on what we need the robot to do,
Yeah.
what kind of movements it needs to make.
Right. So there's no one-size-fits-all approach. It's all customized, kind of like tailoring a suit for the robot.
Exactly.
Okay.
And that level of customization is a big part of what makes humanoid robots so incredible.
Okay, so we've got the bones, the muscles, we've even got the power source. But what about the brains of the operation? How does all of this actually come together and work?
That's where the world of electronics takes center stage. We're talking microcontrollers acting as the brain, printed circuit boards, PCBs for short, that essentially form the nervous system.
Wow.
It's like a miniature city of electronics all packed inside the robot.
A miniature city. Paint me a picture. What's going on in there?
Well, imagine like a city map with electronic highways connecting everything. That's essentially what a PCB is.
Yeah.
It's the communication network that allows all those different parts of the robot to talk to each other.
So the microcontrollers, like City Hall, making the decisions, sending out the orders.
You got it. The microcontroller takes in all the information from the sensors, then makes decisions based on its programming, and finally sends those signals out to the actuators telling them how to move.
Wow. It's amazing how they can fit all of that technology onto such a tiny board. What kind of advancements have made this miniaturization possible?
Well, it's a combination of things, really. The incredible advancements in microchip technology, more efficient circuit designs, and of course, the insane precision that we have in manufacturing these days.
It really is remarkable, isn't it?
It is, it really is.
But I want to go back to those hydraulic and pneumatic systems for a sec, if you don't mind. I think I get the basic idea, but how do they actually create those smooth, lifelike movements? It seems pretty complex.
It is intricate, but I'll give it a shot. Imagine like this network of veins and arteries carrying power throughout the robot's body. That's essentially what a hydraulic system is. It uses pressurized fluid to transmit force, and when that fluid gets pumped into a cylinder, it moves a piston,
Right.
and that piston moves a joint. So it's kind of like a really controlled muscle contraction, and it can create an incredible amount of power.
So that's how you get those strong, powerful movements, huh?
Yeah.
It's amazing how you can make it look so smooth.
Right. And then you got pneumatics, which is similar, but instead of fluid, it uses compressed air.
Mm.
The air is stored in a tank and then released to create movement. Now, air is more compressible than fluid, so pneumatic systems are generally better for tasks that need a softer touch, like handling delicate objects.
So if hydraulics are like a power lifter, then pneumatics are more like a skilled surgeon.
Yeah.
It's precision over brute force.
Yeah, that's a great analogy. And the cool thing is we can actually combine these systems depending on what the robot needs. So a robot might have hydraulics for heavy lifting and then pneumatics for like fine motor control. It's all about picking the right tool for the job.
It's like giving the robot a whole arsenal of ways to move. But with all these systems working together, how does the robot know what to do and when to do it? We talked about microcontrollers being the brain,
Yeah.
but how does that work in practice?
Well, the microcontroller's constantly getting information from all those sensors we talked about.
Right.
And it processes that data based on its programming. Then it sends commands out to the actuators telling them how to move. It's like a conductor leading an orchestra, making sure everything plays in harmony.
So the sensors are providing the input, the microcontroller is making the decisions, and the actuators are carrying out those decisions, like a feedback loop, constantly adjusting to what's happening around it.
Precisely. And all of this communication is happening through those intricate printed circuit boards, the PCBs.
Right.
They're like the nervous system of the robot, relaying signals back and forth between the brain, the senses, and the muscles.
It's amazing when you look at a PCB to think about just how tiny and complex those things are. What are some of the challenges in designing these electronic highways? I mean, making sure it all works together seamlessly.
Oh, it's definitely a challenge. PCBs have to be incredibly precise. Every component has to be perfectly placed to avoid any interference and make sure the signals flow efficiently. And as robots get more complex, more sensors, more actuators, those PCBs get even more densely packed. It's like designing a miniature city with millions of tiny pathways, all interconnected.
It sounds like a monumental task.
Ah.
But let's talk about those sensors for a bit. They're the robot's window to the world, right? So how do they help it perceive and interact with its surroundings?
Absolutely. Sensors are the robot's way of understanding the environment. They provide this crucial feedback that allows the robot to avoid obstacles, navigate spaces, interact with objects. It's like giving the robot a whole bunch of extra senses.
Okay, so we talked about gyroscopes for balance.
Yeah.
What other kinds of sensory input are we talking about here?
Well, for movement, accelerometers are super important. They measure acceleration so the robot knows how fast it's moving and in what direction. That's essential for smooth, controlled movements, especially when interacting with humans. You wouldn't want a robot that's jerky and unpredictable.
Safety first, for sure. So what about proximity sensors? How do those help the robot avoid bumping into things?
Think of proximity sensors as the robot's personal radar system.
Okay.
They use different technologies, things like infrared or ultrasonic waves,
Right.
to detect objects without actually touching them. And by emitting a signal and then measuring how long it takes to bounce back, they can figure out how far away an object is.
So the robot can sense what's around it, even if it can't see it directly.
Exactly. That's really important for things like navigating tight spaces, avoiding collisions, even picking up objects without crushing them. It's like giving the robot a sixth sense, spatial awareness.
And then you've got touch sensors, which I guess are pretty self-explanatory. But why are they so important for a humanoid robot?
They might seem simple, but touch sensors are crucial for any robot that needs to interact with the physical world. It lets the robot know when it's making contact with something, whether it's a person's hand, a delicate object, an obstacle. This feedback is what helps the robot adjust its grip, make sure it's not using too much force, and just generally interact safely and in a controlled way.
It's like giving the robot a sense of touch, which seems vital for tasks that require dexterity and finesse.
hmm
Are there any other types of sensors that help with those finer movements?
There are force sensors, for example.
Right.
They can actually measure the amount of pressure that's being applied. Really important for handling delicate objects or doing like precision assembly.
Hmm.
By sensing how much force it's applying, the robot can avoid damaging things or dropping them.
It's incredible how all these different sensors work together, giving the robot this really comprehensive understanding of its surroundings. It's like building a multi-dimensional map of the world for the robot to navigate.
That's a great way to put it. And it's all of this sensory information that gets fed into the robot's brain, allowing it to make decisions and interact with the world. But it's not just about perceiving the world, right? It's about understanding that information and making intelligent decisions. And that's where artificial intelligence comes in.
Right, AI. It seems like that's the key to unlocking the real potential of humanoid robots.
hmm
But can you explain in simple terms what AI actually means in the context of robotics?
hmm
Because it feels like such a buzzword these days.
I know what you mean. It's everywhere. But essentially, AI gives robots the ability to learn from experience, adapt to new situations, make decisions without needing us to program them for every single scenario.
Okay.
It's about moving beyond those rigid, rule-based systems, the ones that can only do what they're explicitly told to do. AI is about flexibility, adaptability.
So instead of just following instructions, the robot can actually learn, evolve over time, and become like more intelligent, more capable.
Exactly. AI algorithms, they allow robots to analyze data from all those sensors we were talking about, recognize patterns, and even predict what might happen next. This is what lets them handle those complex tasks, solve problems they've never encountered before, even interact with humans in a more natural, intuitive way.
It's like they're developing a kind of intuition, an ability to really understand what's going on and make smart decisions.
That's a great way to think about it. AI is definitely pushing the boundaries of what robots can do, blurring the line between just being a machine and, something that feels almost sentient.
It's exciting, but also a little unnerving, isn't it? To think about the idea that we're creating machines that can learn and adapt like that.
It definitely raises some big questions, about the future of robotics, the whole relationship between humans and machines. But you know what? Let's stick to the practical stuff for now. How do we power these incredible machines? We touched on lithium-ion batteries before, but I'm curious about the whole challenge of keeping a humanoid robot running. They must require a lot of energy to function.
That's a good point. It's not just about building it. It's about making sure it can keep going. So what are the big challenges in power management for humanoid robots?
Well, they have a lot of systems that are really power hungry,
Right.
motors, actuators, sensors, not to mention the AI processing unit. So it's not as simple as just slapping in a huge battery. It's about using that energy as efficiently as possible.
Right. So it's a balancing act. Power versus efficiency. How are engineers tackling this? What are some of the strategies they're using to make these robots more energy efficient?
One approach is all about optimizing the robot's movements, making sure no energy is wasted.
Okay.
So that might mean designing the limbs to be lighter, using smoother, more efficient trajectories. It's like finding the most graceful way to move, the one that uses the least energy.
So it's not just about the software and electronics. It's about the physical design of the robot, too.
Yeah,
Everything plays a part.
absolutely. Another strategy is to use something called regenerative braking.
Ah, yes. I've heard about that.
It's similar to what you see in electric cars, Yeah, yeah.
When the robot slows down or stops, the motors can act like generators, turning some of that kinetic energy back into electricity. And that goes right back into the battery. It's like a little boost of energy every time you brake.
That's so clever. Any other, like, energy-saving tricks up your sleeve?
Oh, there's tons. One that's pretty cool is using variable speed pumps in the hydraulic systems.
Mm.
So traditional hydraulic pumps, they run at a constant speed, which can waste a lot of energy if the robot's not using its full power all the time. But variable speed pumps, they can adjust their output based on what the robot needs. So they only use as much energy as they have to for a specific task.
It's like having a dimmer switch for the robot's muscles.
Exactly. It's amazing how much thought goes into every single aspect of these machines,
It really is.
from the big picture down to the tiniest detail.
It makes you appreciate the level of engineering that goes into all this.
But power management is just one piece of the puzzle, right? As we create more advanced humanoid robots, we need to keep pushing the boundaries of battery technology, energy efficiency, sustainable design, all that.
You're absolutely right. Building a humanoid robot is truly a multidisciplinary effort,
Right.
pulling in expertise from so many different
It's
fields.
incredible, isn't it?
It is. And as we dive deeper into the world of AI, we're going to need even more collaboration
Right.
between roboticists, computer scientists, ethicists,
Right.
to make sure these technologies are developed and used responsibly.
Speaking of AI, let's get back to that. We talked about its potential to make robots smarter, more adaptable. But can you give us some real-world examples of how AI is actually being used in humanoid robots right now? What are these robots capable of doing thanks to AI?
One area that's just mind-blowing is natural language processing. AI-powered robots can now understand and respond to human speech in such a sophisticated way. It's incredible. You can actually hold a conversation with a robot, ask it questions, give it instructions.
Yeah.
You can even have a bit of back and forth banter. So we're not just talking about pre-programmed responses. These robots can actually understand and process human language.
Exactly. They can understand the meaning behind what you're saying, figure out your intentions, and even tailor their responses based on the context of the conversation.
Wow.
It's like having a real dialogue with a machine, which opens up all sorts of possibilities for, how humans and robots can interact.
That is wild.
Yeah.
What about tasks that require, like, physical dexterity, coordination? How is AI helping with that?
AI is transforming the whole field of robotic manipulation.
Okay.
Robots can now use AI to grasp objects of different shapes and sizes, use tools with incredible precision, and even assemble complex things.
So we're talking robots that can build things, fix things, maybe even cook a gourmet meal.
All of that is definitely on the table.
Oh.
And more. The key is that AI gives them this ability to adapt or to handle the variations and uncertainties of the real world, just like humans do. They can learn from mistakes, adjust their grip, come up with creative solutions to unexpected problems.
It's like they're not just following instructions, they're actually understanding the task and figuring out the best way to do it.
Exactly. And as AI continues to evolve, these robots are only going to get more impressive, more human-like.
It's both exciting and, I gotta say, a little daunting to think about all the implications. Where do you see this technology going in the next few years? What are you most excited about?
I am really excited about the potential for AI to push the boundaries of how robots learn and adapt, in real time. Just imagine robots that can not only do tasks, but also learn your preferences, anticipate your needs, even pick up new skills just by observing and interacting.
Wow.
It's about going beyond programmed intelligence,
Yeah.
getting to something closer to human intuition and creativity.
That sounds almost like something out of science fiction. But it's pretty fascinating to think about how these technologies could change not just how we work, but how we live,
Yeah.
how we interact with the world around us.
Absolutely. And as we build these incredible robots, it's important that we think about the ethical implications as well. Make sure these technologies are used responsibly and for the good of everyone. It's a conversation we need to have alongside all the advancements in the tech itself.
Well said. And that brings us back to the heart of what we've been talking about today, right? This deep dive. It's not just about the mechanics of building a humanoid robot. It's about understanding the impact of this technology and its potential to change our world in ways we can only imagine. It really feels like we're on the verge of something huge.
I think so too. And it's not just the technology, it's what it could do. I mean, think about all the things we humans can do. Now imagine a robot that could do all of that, maybe even better in some ways.
It's mind-blowing, but it also kind of makes you wonder, what does it mean for us,
Mm-hmm.
for humanity?
Yeah.
Where do we sit in if we're surrounded by all these super intelligent machines?
That's the million-dollar question, isn't it? And it's one we need to really think about.
Right.
Personally, I think these humanoid robots, They have the potential to be incredibly beneficial to society. I mean, just imagine. They could take over those jobs that are dangerous, tedious, or just plain physically demanding.
Right.
They could help care for the elderly, work in disaster zones, explore places that are hazardous for humans.
It's like having this tireless, adaptable partner helping us tackle some of the world's biggest problems.
Exactly. But of course, like with any new technology, there are potential downsides, things we need to watch out for. We need to be really thoughtful about how we design, develop, and use these robots to make sure they're used responsibly and ethically.
So it's not just about overcoming the technical challenges. There are these societal and ethical considerations that come into play too. We need to make sure we're steering this technology in the right direction.
Absolutely. And that means having those open and honest conversations about, the potential impact of humanoid robots on the workforce, our privacy, even our understanding of what it means to be human. They're not easy issues, but they're ones we can't ignore.
It sounds like there's a lot of work ahead, not just for the people in the lab, but for all of us. Definitely. But I'm optimistic. I think if we approach this technology thoughtfully, work together, we can create a future where humans and robots coexist, where we work side by side to build a better world.
It's a hopeful vision, for sure. Well, I think that about wraps up our deep dive into the world of humanoid robots. We've covered so much today, the materials, the mechanics, the intelligence, even the big philosophical questions. And one thing's clear, this is a field that's moving fast, and it's full of incredible potential and some really complex challenges.
It's been a fascinating journey, and I hope you, our listener, have a better grasp of not just how these robots are built, but also the broader questions they raise about the future of technology and, what our place in that future will be.
And to you listening, thank you for joining us on this deep dive. Keep exploring this amazing world, keep asking those questions, and be a part of the conversation that's shaping the future of robotics. Who knows, maybe one day you'll be the one building the next generation of intelligent machines.
Until next time, keep learning, keep questioning, and keep those imaginations running wild.
And remember, the future is in our hands.